So graphing quadratics is one of the things that we are going to be doing in class. You may have already started doing it. Graphing quadratics is quite simple, but you really need to understand the relationship between the different forms of polynomials. So the one that you most often see is standard form, but then you should be able to convert it to factored form. And if you already know vertex form, you probably are beyond this video, but you can still kind of use these ideas. Hopefully this method is somewhat intuitive, so that you don't have to rely on formulas and that you know where each part is coming from. So we're going to avoid formulas by really digging into the math. So these are my notes if I were to have a note card of how to graph a quadratic. So there are really four main parts that I really want. I want to know the x-intercept, so that's where it crosses the horizontal axis. And the first thing I need to do is factor and then set y equal to 0. Once I set y equal to 0, I have to think to myself, what x values make this 0? So we'll talk through that in a moment. Next, I need to do the y-intercept, and all that takes is setting x equal to 0. There's another way, if you understand the standard form, to understand where the y-intercept is in standard form. We also need to understand the line of symmetry. Where is that? How do I calculate it? There's some really important properties of quadratics when you're graphing them, where the line of symmetry is. And finally, understanding where the vertex is. The vertex is the maximum or the minimum, and it's pretty straightforward once you know the line of symmetry and that special property about this line of symmetry. If we just substitute that x value into the equation, similar to the way that we do for y-intercepts, then we can calculate the vertex. So let's start with a somewhat simple problem. I know that there's a common factor, but if we're able to factor, it shouldn't matter how we do it. So the first thing I'm going to do is go ahead and factor this thing. Probably used up too much space there. So I got 2x squared and 10. I know that multiplies to 20x squared, and it needs to add up to 12x. So things that multiply to 20x squared that add to 10x, add to negative 12x, negative 2 and negative 10x. Okay, so I'm actually just going to go erase that because I'm probably going to need that space. So negative 2x and negative 10x multiply to negative 20 and add to negative 12, multiply to positive 20 and add to negative 12. Okay, so finding my factors, I see I have, up here it's a 2x, goes into both of those, and then x, and then negative 10, that means this has got to be a negative 1 to get negative 10, and that fixes all my problems. So in factored form, this polynomial is 2x minus 10 times x minus 1. So I've done step 1, I factored this polynomial. Now I need to think, what values of x get us to 0? So I think, I know that if 2x minus 10 equals 0, and 2x equals 10, and that x has to be 5. So that's one of my roots, and so I'm going to go plot that on this picture. X is 5, and then, x has got to be 1, and that will be my other point. Because if x is 1, then 1 minus 1 is 0. So we're using this idea of the zero product property, setting this equal to 0 to determine the roots. So I found the x-intercepts. Now I need to find the y-intercept. And if you go back to the beginning of this video, to get the y-intercept, I just set x equal to 0. And I can do that in either of these equations. So I can do it in 2 times 0 squared minus 12 times 0 plus 10. That's 0, that's 0, and I'm left with just 10. So it looks like my y-intercept's 10, but let me show you with the other equation. So if I do 2x minus 10 times x minus 1, I can do 2 times 0 minus 10, and 0 minus 1, that's negative 10 times negative 1. Oh, that's positive 10 as well. So my y-intercept, it looks like, I don't have enough space up here, but it's going to be up here at 10. If I had enough space, it would be up here at 10. But it just doesn't always show up on my graph. So where is my line of symmetry? Well, the line of symmetry is always perfectly in between the x-intercepts, and my x-intercepts are 1 and 5. 1 and 5. So what number is perfectly between 1 and 5? Well, I know that we can count on the line, but I just want to show us a way to do it so that we don't have to worry about that. So if I'm going to climb the line of symmetry, I'm going to add the two vertex points, 1 plus 5, and then divide it by 2. I'm taking an average, so that's 6 halves or 3. So the line of symmetry is here at 3. Okay, and I know that the line of symmetry is also where the vertex lies. So to calculate the value of the vertex, we're going to have to substitute the line of symmetry into that. So my vertex, the x-coordinate is going to be, 3, because that's what my line of symmetry is. So 3 for sure. Now how do I get my y value of the vertex? Well, I just plug it in. And I'm going to plug it into the factored form because I think that's easier for me to calculate. So 2x minus 10 times x minus 1. I substitute the line of symmetry in. So 2 times 3 minus 10 times 3 minus 1. 6 minus 10 times 3 minus 1 is 2. So that is negative 4 times 2 is negative 8. So the y value of my vertex is negative 8. So 3, negative 8 is my vertex, and I'm going to plot that on my grid. And now I kind of have all of the points that I need. And I know that I have to draw kind of a curvier line than maybe you're used to. And this is probably going to be awful, but I know the vertex is there, my roots are there, and it's a terrible drawing, but it goes through all of the points that it needs to go through, and it kind of looks quadratic-y. So in this kind of demonstrates all of the steps to graphing a quadratic. I've tried to color coordinate it so that the y-intercept is blue, the x-intercepts are red, the line of symmetry is green, and the vertex is black. If that helps you out, then hopefully you can pause the video and kind of explore how I did all of those pieces. And as always, you can always email me if you need to. So this is very similar. People kind of get confused when they see, oh, there's no 0, or there's no ones value. Well, it's just plus 0. And hopefully you can see that. That's going to actually make our job a little bit easier. But if you didn't see that, you can always see, oh, we've got a common factor in this problem. So we could rewrite this as x times x plus 5. And then, oh, it's already now in factored form. So what values get this to 0? I'm going to color coordinate it red. So one of the values is 0, and the other value is negative 5. X equals negative 5. So negative 5 and 0. Oh, look, we don't need to do a y-intercept because our x-intercept happens to be the y-intercept here. If you can see that right here, that it also crosses this barrier, so it is our y-intercept. So we don't need to do any work or calculations to find the y-intercept. Now, to get the line of symmetry, I'm going to do the line of symmetry in green, line of symmetry in green. I just take the average of the x-intercepts. So 5 plus 0 divided by 2 is 5 halves, or, oh, it's negative 5. Oh my gosh. Negative 5 halves, which is negative 2.5. It's not on anything nice. It happens to run down this line. Oh, I hope I did it. Okay. It's a little bit crooked in the center. Let me fix that. It's a little bit crooked, so I'll redo it. Right down. There we go. That's about as straight as I can get it. So then all I need to do is the vertex, which means I substitute the line of symmetry into the equation. So we can get negative 2.5 times negative 2.5 plus 5. And I can't do this in my head, so I'm going to grab a quick calculator and know that 2.5, so I guess I can do that in my head. 2.5 times 2.5. And I'm not going to even risk it. So 2.5 times negative 2.5 is negative 6.25. And that's going to be on the line of symmetry. And we don't have to be absolutely perfect, but we know that we've got a curve that goes through those points. I'm going to connect all of the points with a curve, and I've got my quadratic graphed. I'm going to recommend pausing the video to try this one on your own, and when we come back, you can watch me demonstrate how to do it. But again, I recommend that you stop and pause the video so that you get a moment to do this on your own. Remember to factor, set it equal to 0, find the y-intercept, then find the line of symmetry, and substitute the line of symmetry to find the y value of the vertex. Okay, hopefully at this point you have graphed this and tried it on your own, and now you're watching it to watch how it goes. So 4x, I know that something that multiplies to 3x that adds to 4x is 1x and 3x. 1x and 3x, and so I've got 3x, x, and 1. So my factors here are my factored form is x plus 3 times x plus 1. And then I'm going to look for what values make that 0. So x equals negative 3 makes that one 0. And x equals negative 1 makes that one 0. So I've got x-axis is x-intercepts at negative 1 and negative 3. And then I'm going to do the y-intercept. So I'm going to substitute the y-intercept. I'm going to substitute 0 into the equation. So 0 plus 3 times 0 plus 1. So that's 3 times 1, or just 3. So I got my y-intercept on the grid. Now I need my line of symmetry. And that's the average of the x-intercept, so negative 1 plus negative 3. And then we're taking the average of that, so that's negative 4 over 2, or just negative 2. So I'm going to draw that in as best I can. This is always the hardest part. The line of symmetry is this big green line, and it goes through 2. It's not anywhere else. And then I'm going to find my vertex by substituting the line of symmetry in. So I've got my vertex is going to be negative 2 as its x value, and we're going to find that y value by plugging it in. Negative 2 plus 3 times negative 2 plus 1. So that's 1 times negative 1, or just negative 1. So negative 1 right there. This is kind of a cool one, actually. Let's see if I can draw it a little bit better. There we go. And then it goes off in both directions to infinity. I hope this video was instructive. There really are only a few parts. Now you might, if you go through the internet, find some formulas for finding the vertex. I don't like to use those formulas for finding the vertex because you need calculus to be able to figure out why they're useful. And here in an Algebra 2 class, I don't think that we should be using something that requires calculus to get us an answer. So I would recommend this because it's stuff we've looked at before. It's somewhat intuitive. If you're really interested, I recommend exploring why do we substitute x equals 0 to get the y-intercept, because I think that is a useful exercise in understanding why we do stuff like that. So I hope this video was useful. Good luck, and thanks for watching.